you have any specific questions?
Yes, actually, I had a question about the last assignments.
Okay, which one?
Um, yeah, just a second, about the last one that we have for the last week, I think.
What was the question? Can you give me an idea what the question was?
Um, okay. I don't see the assignments, Professor.
What did you say?
I don't see the assignments, maybe because it was due April 3rd,
Okay.
so I don't see it no more.
Well, I mean, you should at least copy it. Let me see if I can bring it up. All right. I'm going to reopen it.
Okay. It is week 8, module 8.
Okay.
It was due April 3rd.
Yes, I'm going to, that is the Buena Reg assignment. All right, so that is the assignment that wants you to test a hypothesis test and also wants you to do a regression analysis. Am I correct?
Yeah.
Okay. So what specific questions do you have about it?
But I don't see the questions. It was a question that it was, I think, the third questions about the, to calculate about the 200 miles, or I don't see the questions right now.
Well, go back and refresh. You will see it now because I just opened it.
Okay, just a second.
Okay.
Okay, I don't know. I still don't see it.
Let me pull it up. So I'm going to share my screen. Are you seeing my screen?
Yes.
Okay.
Okay, so it is this one. The fixed, what is the estimated cost of maintenance for a bus that is driven for 6? This question.
Okay. All right. So
Can we make an example at least of one of these 670 miles?
Okay. Now the thing in it is, first of all, you have to estimate a regression line.
Yeah.
Okay. You have to estimate a regression line, and then you find the intercept and you find the slope, and then using the intercept and the slope, then you can estimate what it will cost to maintain a bus that has driven 670 miles or 750 miles or 850 miles. So let us go through that process to estimate a regression line. All right. So that is the first thing we're going to do today. We're going to talk about the regression line. So I'm going to stop sharing this screen, and then I'm going to go through a regression estimation. And from that, you can solve the problem. You understand that?
Yeah.
Okay. So let's share a screen. Let me share my screen for doing regression analysis. All right.
Okay.
So that means hope that this is new screen. This is the screen for the last lecture where we tested a hypothesis for two sample means. So this is not the screen we're looking for. Okay, you see my screen that says simple linear regression?
Yes.
Okay, so like I said, the the way you can solve that problem is to first of all estimate a simple linear regression line. So we're going to talk about simple linear regression, and then we're going to apply it to that problem. Okay. So
Okay.
now all along we have been talking about test of hypothesis for say a mean. Okay. So say the average travel time, the average cost, the average age, the average price of a house. And the average price of a house is one variable. And you're trying to test a hypothesis about that one variable. Now, when you're doing regression analysis, you are looking at two variables. Okay, you're looking at two variables. One variable is called a dependent variable, and the other variable is called an independent variable. And the whole idea is that the values of one variable depend on the values of the other variable. For example, we can say that the amount of money that you spend on clothing depends on your income. Those people that have more money spend more money on clothing because they can afford more money for clothing. So the amount of money that you spend on clothing depends on your income. The amount of money you spend on clothing is the dependent variable, and it depends on your income, how much money you earn. That is what regression analysis is all about. Now, having said what regression is all about, or regression analysis is all about, what is regression analysis based on? Okay, regression analysis is based on a linear model. That's the linear equation. It depends on a linear equation, and the linear equation is the equation of a line. The equation of a line that you specify in algebra, and the equation of a line has a constant, and then it has a slope. Now, so we're going to be talking about the relationship between two variables. One is called a dependent variable, and the other is called an independent variable. And so the thing, what are we going to discuss? What is the relationship between two variables? Okay. First of all, we want to know about the nature of the relationship. Is it a negative relationship, or is it a positive relationship, or is that it's none? Okay. If it's a negative relationship, It simply means that as the independent variable increases, the dependent variable decreases. For example, if you are driving a car, how much gasoline that you have in your vehicle depends on how far you are driving. Okay? So if you drive 10 miles, then the amount of gasoline in your vehicle will decrease. If you drive 20 miles, the amount of gasoline left in your vehicle will also decrease even more. So the amount of gasoline that you have in your vehicle as you are driving is negatively related to the distance that you drive. So the higher the distance, the less gasoline. Another example would be the price of a good, okay, and how much people want to buy of that good, which you learn about in supply and demand. And so the idea here is that the higher the price, the lower the quantity demanded. So that's a negative relationship. Now think about your utility bill, okay? Now, when you have utility in your house, when you have electricity or you have gas, that's a minimum amount that you must pay. Okay, that minimum amount is the constant amount. Whether or not you use any gas, whether or not you light your house, that's a minimum you pay. Okay, but the more gas you use, the more money, the bigger your bill. Your bill is going to get higher and higher. So the amount of your bill is the dependent variable. And the dependent variable here, the independent variable is the amount of gas that you use. And so in that case, you have a positive relationship. The higher the independent variable, the higher the dependent variable, okay?
Okay.
The next thing that we need to look at is the size of the relationship, okay? So for example, when you get your bill, you find that after you pay the constant amount, maybe $20, then for every 1 kilowatt hour, what happens? Your bill goes up by 15 cents. So the size of relationship in this case would be 0.15 or 15 cents. But let us say you go to another location that is not New York. That would be that the extra kilowatt hour that you use, the additional amount will be 25 cents. So in that case, the size of that relationship is 0.25 or 25 cents. Then the other parameter that we want to find out about in a linear regression is how strong is the relationship, okay? How strong? How strong meaning is your bill explained entirely by how much you use, okay? Or let us say, is the amount of gasoline that is left in your tank depend 100% on the distance that you travel? The answer is no, because yes, the longer you travel, the less gasoline you're going to have. So there's a negative relationship, but also other factors such as the road that you're traveling. If you're traveling on a bad road that makes you slow down and make you brake more often, you end up using more gasoline. Okay. If you are driving in the congested traffic, you end up using a lot of gasoline just for idling. And so the distance that you travel does not explain 100% of the amount of gasoline in your car. So that is what we do in regression analysis. Now, so in order to do a regression analysis, we have to estimate this equation of a line that you already know. Y is equal to A plus B times X. Okay. Now, X is the dependent variable. I'm sorry, X is the independent variable and Y is the dependent variable. A is the constant value, that minimum amount that you must pay for your utility. That is A. And then the slope or the rate of change is the additional amount of money that you pay for each additional kilowatt hour or the additional unit of energy. Okay. So when X changes by 1, Y will change by B, but you have to estimate B, okay? For example, Y is equal to 10 plus 5X. Okay, this is a positive relationship. So when X is 3, for example, say X is 3, if you take 3 and multiply by 5, what do you get? You get 15. 15 plus 10 will give you 25. Is it clear so far?
Yeah.
Okay. So suppose you have a negative relationship where Y is 25 minus 2 times X. Okay. And so if X is 3, then you multiply 2 by 3, you get minus 6, and 25 minus 6 is 19. All right. So that is what a linear relationship looks like. And this is how to work with a linear relationship. So the problem that you have in your assignment is going to, the way to solve it is to estimate this linear relationship, which we're going to do very soon, okay? All right, so again, as we said, we're going to try to estimate Y is equal to A plus BX, okay? Where A, for example, will be the minimum cost of maintaining a bus, okay? Because even if you don't drive the bus, you're still going to change the oil every 3 months or every 6 months, depending on the kind of vehicle. And then if you drive the bus, then for every additional mile, how much does it cost you to maintain the car? All right. So the objective of regression analysis is to use data to estimate A using what they call A hat. And A hat is the estimate of A, and to estimate B using B hat. B hat is your estimate of B, okay? B hat is an estimate, it's a sample estimate, and B is the true value. We don't know what the true value is. This is why we do statistical analysis, okay? So our first example that we're going to do will be the example on sales and sales cost, okay? What does this mean? We are looking at data of sales people, sales personnel, salesmen, saleswomen, okay? Now, the thesis here, or the theory in this problem, is that the more sales calls you make, which is the independent variable, then the more sales that you make, okay? So the amount of sales that you achieve depends on the number of sales calls, all right? But sales calls alone do not decide how much you sell, okay? Your personality, your ability to convince people, your luck, okay? If you call somebody that doesn't have money, they're not gonna buy, all right? But the more calls you make, the higher the chances that you will run into somebody that has money. All right, so let us see how to estimate B hat, okay? So we have the equation Y is equal to, so let's, okay. So we have Y equal to A plus B times X, okay? So we're going to estimate A using A hat, we're going to estimate B using B hat. So what I'm going to do is I'm going to pull up the actual data, okay? This is the data here, but I'm going to then show you how we're going to do the estimation, okay? We're going to do the estimation using a formula, what we call a regression formula. And that regression formula is that you estimate B hat using summation X minus X bar times Y minus Y bar divided by summation x minus x bar squared. Well, how do you get these numbers? So that is what we're going to find out now. All right. Okay.
Okay.
So I'm going to stop this share and bring up the file. Okay. So this is a file that shows you. I'm going to share it. Sorry. All right. Are you seeing my regression, my spreadsheet file?
Yes. Yeah.
Okay. All right. Remember the formula that we said we're going to use. Okay. And the formula, as we said, is the summation x minus x bar over y minus times y minus y bar divided by summation x minus x bar squared. So first of all, you have to get x bar, okay, which is the mean of the x values, okay? And then we're going to find y bar, which is the mean of the y values, okay? So let's see. All right, so here we're going to find the average of the x values. So I'm going to make sure that you're seeing everything. Okay, so this is sales, the amount of sales, okay? So we're gonna find the average of okay. So the average of the sales is called y bar, or the sample mean. So we're going to find the average. Okay. So this is the average of the sales. We're going to find the average of the sales calls. Okay. So now we're going to take y minus y bar, okay, which is y. We take every single value of y and subtract it from the mean of y. The mean of y is right here. So we're going to go equals C5 minus $C $20. All right. So we're going to subtract every value of y from the mean of y. Going to highlight that, put it in bold. Okay. So you know that is what we're subtracting from. Drag it down. All right. And you do the same for the x's. All right. And so we're going to go equals 5 minus $D $20. Okay. And we drag it down. Okay. So this is $D $20. Right. Sure. All right. So now you have the deviations from the mean. See, have the deviations from the mean. Remember that the formula is the sum of x minus x bar times y minus y bar. So you then here, this is x minus x bar times y minus y bar, and you multiply y minus y bar times x minus x bar. I'm going to, this is what you multiply. Multiply these two numbers. I'm going to highlight that in green, make it bold. Okay, so these are the two columns that you multiply. You multiply those two columns. So that will be equals E4 times F4. 5, F5. All right. And then you drag it down. Okay. All right. So you multiply those two columns, and then you then take each of E and each of F, and you get the this belongs there. Okay. Then you take you take E and you take F individually, and you square them. That is to say, you square E5, you square E6, you square E7. So this will be equals E4 y minus y bar squared to the power 2. I'm sorry, E5. Why am I talking from 4? All right, you square those. All right. And then you square the F's also. Okay. Square that too. All right. So now you take the sum, of these manipulations, these calculations. And so you take that sum, take all these sums. And so what do you have? So you have the sum. These are the sums here. These are the summations. Okay. So these are the summations, and I'm going to highlight that in red. Okay. Highlight in a different color. So you take the sums. All right. So now let's go back, and we're going to write those sums down. Okay. I'm going to write it down, and I'm going to summation y minus y hat squared is 2326 summation x minus x bar times y minus y bar is 6672, and summation x minus x bar squared is 25,600. So now you manipulate them in Excel, okay? So, but you can write it down and then transfer it to a formula. All right. So I'm going to stop this share and bring up the PowerPoint slide that we were working with. Let's hope we're right. Okay, so this is where we were. Okay, this is where we were. Okay, so we said that B is summation x minus x bar times y minus y bar. So let us write down those numbers that we had. We copied them down. Okay. And we found that to be 6672. And then summation x minus x bar squared. We found that to be x minus x bar squared 25,600. 25,600. All right. So that is what okay. So from that, what do we have? We have an equation. Okay. We have 6672 divided by 25,600.
100, yeah.
Okay. So what is your calculation? What did you do?
Here it is. So 0.26.
Yeah, 0.26 and some change. Okay. All right, 0.2606. Okay. So 0.2606.
Oh, 6.
All right. So that is a positive number. All right. So that says the more sales calls you make, the more sales that you make. But now we have to estimate A. We have estimated B. Is that correct? Using B hat.
Yeah.
So now we have to estimate A. All right. So A hat is equal to Y bar minus B hat times X bar. We know that Y bar, the average of Y is 45, and X bar,
Yeah.
the average
96.
is 96. And so we then have that A hat okay, A hat is equal to Y bar, which is 45, minus B hat times X. B hat is 0.2606 times Y X bar, which is times 96. So what number do you get? Hello?
Yeah, just a second. I'm trying to make the.
All right.
Uh, 19.98.
19.98. Okay. Now, this kind of calculation, does it make sense to you? Okay.
Yeah.
Okay. The sense it makes is that, when you go into a sales job, I mean, essentially some of the sales come to you. So even if you don't call anybody, you're still going to make about $19,000 worth of sales. Okay. But if you make the effort to call more people, the more people you call, your sales will increase by 0.26, which may be 0.26 of 1,000 or $260,000, whatever it is, okay, or 2,600, but it will increase by 0.26. All right. So you have estimated. So your model equation. So we're gonna say we're gonna use this to create what you call a model equation. Okay. Model. Okay. We're going to create a model equation now that we have estimated this. So sales equals 19.98 plus 0.2606 times X times sales calls, okay, plus error, because your sales call alone does not explain how much sales. Like I said, your personality is part of it. Your luck is also part of it. If you call people that don't have money, they're not going to buy. If you call people that don't like what you have, they're not going to buy. All right. So now let us try to say, what is the estimated sales for a salesperson that makes 30 calls? Okay. So that is the same thing that you're going to do with the boss problem. And I'm going to give you an idea with one of them. Okay. So this estimate for 30 calls will be okay, sales for 30 calls will be equal to 19.98 plus 0.2606 times 30. And what does that give you?
Yeah, just a second.
Yes, go ahead, take your time.
It's 9.98 plus 7.82.
Okay. So that is
27 point. No.
Okay. Well, Omar just sort of like is going through it. You say 7.72?
Yes.
Okay. Which gives us what you need.
No, 7.82.
Okay. So you need what does that give you?
27.77.
27.77. So somebody that makes 30 calls will the estimate. Now this is an estimate. It's not exact. It's an estimate that somebody that makes 30 calls will make 27.77 of sales. Maybe 27,000, maybe 270,000, whatever it is. That is how to estimate it. So that is the same thing that you are expected to do for the boss problem. All right. So let us see. I think that's an estimate. This is the same problem. So now, with your model equation, it simply says that for every sales call, your sales will increase by 0.2626. So you have it there. All right. Okay. These are other examples that we have, and I'm going to put them up. So now let us see if we have the boss problem here.
Professor,
yes.
I have one question.
Yeah.
Did we learn this in the previous class?
In Econ 316, yes, we did.
Yeah,
Yes,
this
we
looks
did, yeah.
familiar.
Yes, we did. Okay. So now this is the boss problem that we have. So I'm going to bring it up. Okay. I'm going to bring it up so that you calculate the slope and the intercept, and it's all here for you. And so you use this to estimate. But this one we were looking at age, but I asked you to look at miles. So you have to do your own estimation for miles instead of age. All right. So once you go through the same procedure and estimate for miles. You get what I'm saying?
Yeah, yes.
Okay. So after you do that, and you can do it using Excel. Okay. And I'm going to stop sharing this screen and show you the same problem that we just did, the same sales problem we just did, how Excel gives it to you, and you can see it. Okay. Are you seeing my screen now?
Professor,
Just a minute. Are you seeing my screen for the sales call?
Yes.
yes.
Very good. You can see B hat, which is the estimate of B. You can see we get the same thing, 0.2606, right? See it?
Yeah.
Okay. So this is B hat. And what I did was to take the summation I, this 6672 here, which is this summation here, and then you divide it by H, summation X minus X bar squared, which is 25,600. And right there, it gives you the same thing. You get A hat from there. You get it? So
Yeah.
you can do it using Excel, or you can write down the numbers and use the formula. Any way you do it, you're going to get it correctly.
Okay.
All right? Okay.
Yeah.
So you can do the same for the boss problem, except that you're going to do it for mileage instead of for age.
Okay.
Let's see. All right. Okay, here it's done for age. I'm going to bring it up.
Professor, will you
Yes.
post this on Blackboard?
Post what on Blackboard?
The video.
Yes, I will post it on Blackboard. Last time, did you come to the last office hour?
Yes,
Last
I did.
week? Yes, I forgot to record it, so I couldn't send it. Okay.
Okay.
Okay, but I'm going to post the PowerPoints anyway, so you can look at it. Now, so the only difference is that when you're doing the boss problem, you're going to do it for mileage instead of for age. The example here is for age, the example that you are seeing in the PowerPoint slide. So let me stop sharing this PowerPoint slide and bring up the slide we're looking at. Okay, so you can see the sales call. Okay, so you can see here that we did maintenance against age. The older the bus is, the more you're going to spend on its maintenance. But your homework assignment is about mileage. So you're going to replace this age here with mileage in your own spreadsheet. And you go through exactly the same formula. You're going to find the slope and also the constant or the intercept. And then let us look at this example here and ask ourselves the question, the same kind of question. So here we apply the formula. and B hat is 15.89, and A hat is 329. Okay. All right. So let us then use the formula. I say the base cost of maintenance is 329, and for each additional year, it will cost 1559. So let us try to use this to estimate what it will cost to maintain a bus that is, say, 12 years. Okay. So let's see if we can ask the question. Let us do an estimate. Cost estimate by age. Okay. What is the estimated cost of maintenance for a bus that is, say, 9 years? Okay. So the model equation is 329, and for each additional year, it costs an additional $15 and so many cents to maintain the bus. All right. So in that case, maintenance M is equal to 329.94 plus 15.5989 times 9. So can somebody give me the answer to that? You working on it? Hello?
Yes.
Okay, so
470.33.
470.33. All right. So your assignment, the difference between this and your assignment is that instead of this equation, you're going to get a different equation, which is going to be based more on mileage instead of age. I do exactly what we just did.
Okay.
You get it?
Yeah.
Okay. So you have any other questions?
Can I, Professor, can I see the assignments, because I can see from mine?
Okay, I'm going to stop share. And I'm going to okay. That's the problem. Are you seeing it?
Yes.
Okay. So when you do your own estimate and you calculate A hat, then A hat will be the fixed charge. Okay. So
yeah.
let me insert that there. Insert. Okay, so this will be your A hat. All right. For each additional mile of transportation, okay, what is the cost for each additional mile of transportation? And so that will be your B hat. Okay. Be your B hat. All right. So what is the coefficient of determination? So now we're going to calculate the coefficient of determination. All right.
Okay.
Okay. The cost estimate will be Y equals A hat equals B hat times X. That will be, and this one, your estimate instead of calling it Y, we're gonna call it Y hat. Okay, because Y hat is an estimate of Y. So this will be what you do after you estimate A hat and you estimate B hat, then you find Y hat, which is that equation. All right, so now, well, for this one, for example, we're gonna have A hat plus B times Y hat times 670. So this will be the estimate for 670 miles. You get it now?
Yes, yeah.
Okay. So that is what you're gonna do. But you have to find your own A hat, you have to find your own B hat, and then you put in 670 here, and that gives you your estimate for 670 miles. You get it?
Yes, yeah.
Okay. All right. So we're going to say that. All right, so then it says, what is the coefficient of determination? So we're going to go and calculate the coefficient of determination, okay? So I'm going to share screen again, different screen.
Professor, is that when we're dealing with R2?
What did you say?
Coefficient of determination.
Yes, that is R squared,
Oh,
okay?
yeah, R squared, yeah.
Okay, so we're going to calculate the coefficient of determination, all right? We're going to do the coefficient of determination for the sales problem, okay? We just went through it. All right.
Professor, is one way that you can find the R squares by finding the correlation and then squaring the answer from that?
Yes, you can. You can. It's easy for simple linear regression, but the reason I'm going to go through the process is that when you are doing multiple regression, that formula will not exactly work. It's not going to be that easy. All right. Okay.
Okay.
So this is the sales problem that we have. So now we're going to calculate the coefficient of determination for that. All right. So the coefficient of determination all right. So the formula for the coefficient of determination is B hat times summation x minus x bar divided by y minus y bar squared. So in that case, we have the numbers. Okay, we have the numbers. So we're going to go bring the numbers that we had used earlier. This is so we did that. All right, so we have x minus x bar times y minus y bar, but we do not have y minus y bar squared. So we calculated y minus y bar squared somewhere. Okay, this is it. Y minus y bar squared is 2326, which we calculated here. All right. Okay. So y minus y bar squared, take it. All right. So r squared will be b hat. We calculated b hat to be 0.2606. All right. Times 6672. I remember that correctly. And this was, what did we get that? The 2238? The 2326. 2326 times 2326. Okay. And so what do you get? Can somebody help me out? Hello? Are we still there? Hello?
Yes,
Okay, go ahead.
uh, 0.0746.
Okay. 0 point. Let's be sure that we have the correct number. Okay. Y minus, oh, y minus y bar squared is 2326. Okay, so we put in the wrong number here. 2326, not 23. Okay. So 2326 times 0.2606.
0.746 now.
Yeah, 0.746. All right. So r squared is 0.746, which simply says that, and let's write it properly, 74.6%, which says that 74.6% of changes in sales is explained by sales calls. So there is still the 25.4% that is not explained by sales calls, which I said to you could be your luck, it could be your personality, and your luck has two parts to it. Somebody doesn't have money, or somebody doesn't like what you have. Okay, so 74.6% of changes in sales performance is explained by the number of sales calls. All right. All right. So again, the other problem that we tried to solve was to ask ourselves whether the estimate that we made, okay, do sales calls significantly affect sales? It might just be that what we have there is just some random number, okay? Does the number of sales calls significantly explain sales? So the number may not be meaningful if we say that sales calls is not really what causes people to have sales, okay? So we test the significance, and we can say that the slope is equal to 0. If the slope is 0, then sales calls has no effect on sales. So we're going to test that hypothesis, okay? We're going to test that hypothesis. I mean, I have other examples here for the estimation that you can use when I post this, okay? Okay, so we're going to do a test of hypothesis, okay? So the test of hypothesis will be the same thing. We're going to have a hypothesis. So I'm going to get the formula for test of hypothesis. We have I'm going to take that formula. I'm going to take it up here. Right. Have a model equation. We have an estimate. All right. Testing significance. All right. So we're going to test significance. Test of hypothesis for slope. Okay. So we have a null hypothesis. Okay. B equals 0. Okay. Sales calls do not significantly affect sales performance. Okay. That is your null hypothesis. Okay. So if the slope is 0, then sales calls, and the alternate hypothesis is that B is not equal to 0. Okay, which means that slope is not equal to 0. sales calls significantly affect sales performance. Okay, so that is your null hypothesis. And of course, you estimate B, okay? You estimate B, which we know is B hat. Then we find the standard error of B hat, okay? Using B hat. So let us again using B hat. And you find the standard error of B hat. All right. And so then you calculate Z, okay? The next thing is you calculate Z, okay? Yeah, this may be, you find the standard error of B hat. And so now you calculate Z, and Z is equal to B hat minus B divided by the standard error of B hat, okay? And if Z is greater than Z star, you reject the null hypothesis. So you reject the null hypothesis that B is equal to 0, all right? And of course, you also calculate the standard error of B hat. So we're going to go through that. But then the next step is you determine, you state a level of significance, okay? So we're going to state a level of significance. So let's go through this process. Hypothesis test. All right. Okay. So state the level of significance. I'm going to say 0.01, which means that Z star is equal to 2.33. We have already talked about how to identify level of significance and the Z star. So we're not going to go through it again. That is a formula. So we use that formula. Okay. We use that formula. So The next question is, what is the standard error of B hat? Okay. Now we already know y minus y. We know y minus y bar squared. We know it's 2326. This is summation here. Just insert the symbol there to make sure. Okay. All right. So this we know is 2326, and n minus 1. What was our sample size? Let me see. Our sample size is 1, 2, 3, 4. Our sample size is 12. Okay, so 12 minus 1. Summation x minus x bar squared. What was it? Let's find out. X minus x bar squared is 25,600. Okay, so we take that out. All right. And so what do we get? Can somebody give me the answer? Hello?
Yes, yeah, just a second, Professor.
All right. Okay. Just waiting. 25,600 times 11. Times 2326. E hat is 0.2606. And the hypothesis is 0. And the standard error B hat is 0.0908, which gives us 2.86, 2.86. So our Z is 2.86. So if Z, which is 2.86, is greater than Z star, which is 2.33, So what do? We reject the null hypothesis that B is equal to 0. All right. And so what do we conclude? We conclude that since the slope is not equal to 0, since the slope is not equal to 0, then sales calls significantly affect sales performance. All right, is that clear?
Yes.
Okay, since we reject the null hypothesis, okay, then sales costs significantly affect sales performance. I think that should be very easy to understand because you're saying that the slope of the function is not 0, which means that B is not 0. So as sales costs increase, sales performance significantly also increases. That is what we are saying. Is that clear?
Yeah.
All right. Yeah. So that is the way you're going to solve the other problem, except that you're going to be talking about maintenance and mileage. Exactly what we just did here. Once you calculate those summations, you're in business. You don't have to do anything else. You just replace age with what do you call it? With mileage. You replace sales costs with maintenance. You can use exactly the same formula that we used here, except that you just change the data set. Just take the same numbers and plug it in and use it. The formula is there.
Professor, you're going to reopen this assignment? Because
yes, I've already reopened it to the end of the week.
Okay.
Okay, so that Monday next week, we're going to talk about multiple regression.
Okay.
All right.
What about the other assignments? Are they reopened?
I did reopen them to match 31. I don't know why some students didn't see it, but I'm going to reopen them again. Send me an email to remind me to reopen them again, but I'm just going to reopen them for another week or so because you just cannot keep falling behind on assignments. It makes it difficult for me to grade them.
Okay.
All right.
Thank you, Professor. Yeah.
All right. So any other question?
No, that's it.
That's it. So I'm going to close all of this and I'm going to send everything, post everything on Blackboard. All right.
Okay. Yeah.
All right. Good night, everybody.
Good night.